We have here, find the GCF of 8ab to the fourth, 20a squared b to the fourth, 28ab cubed. Okay? So, for example 1, we have here 8, again, a b to the fourth, 20 a squared b to the fourth, and then 28 ab cubed. Now, you can list all the possible factors of 8. Excuse me, multiples, not factors, but multiples of 8. Not multiples, I'm sorry. Factors of 8. I'll get it together. Okay? So when you're listing factors of 8, we're talking about, don't forget about 1, because when we get into factoring, really get into it, 1 may be a GCF. That may be all you can do. Okay? So we have 1, 2, 4, and 8. And we'll talk about the variables. Then, for 20, you have here, then we have 20, which is what? 1, 2, 4, 5, 10, and 20. And then 28, we have 1, 2, what's that? 4, 7, what else? 14? And 28. Now you can go by and list the list all the possible factors, okay? But we want to find the greatest one. Now what we see in common, what are some common factors? We see 1, 2, and 4. But we're looking for the greatest. 4. Okay? Now, when it comes to variables, let me say this. I don't have it listed in here. In order for you to find a GCF, it must be something that you can, it depends on how many terms you have in the polynomial, but you want to be able to take out from every, if let's say that you have a polynomial of 4 terms and you're looking for a GCF, you want to be able to take something out of all 4 terms at the same time. It can't be one without the other. Okay? So if you couldn't, if one of the factors, let's say one of the factors here was a 3. Let's say that there was a third expression here, and let's say the number was 3. Okay? Well, other than 1, there would be no GCF. I need you to understand that. But for our variables, like for this example, we have at least an a in each one, but one of these has an a squared. When you're looking for the GCF for a list of common variables, you're looking for the smallest. The smallest, one that's raised to the smallest power. So we have an a, we have an a squared. What would be the GCF of that? A. Look at your b's. You have a b to the fourth, you have a b cubed. A b cubed. See, your GCF wouldn't be b to the fourth, okay, because remember you're looking for, if we wrote out, let me just write this out for a second. Here we have 4 b's, and we can do our a's too. You want to look for something that's common that you can take out. That can be factored out. That's the same. You have a set of a's that counts as 1, not a times a times a. It counts as 1. You can take an a from out of each of this. Then your b, you wouldn't say that you can take 4 b's because you have one that has b cubed. You want to take an even amount. So here's one set, here's another set, here's a third set. That's where the b cubed comes in. Okay? So this is how we find the GCF. Now, we're not going to be able to do each question like this, but some of these we'll be able to see and be able to recognize the GCF. Now, looking at the greatest common factor for a polynomial. It says here, find the expression of the highest degree and largest integer coefficient that is a factor of each, underline that word each, each term of the polynomial. Divide this factor into each term of the polynomial, resulting in another polynomial factor. Your answer will look like this. Whenever the very first question, and from here on out with factoring, ask yourselves, is there a GCF that can be factored out? Either you're going to say yes or no. You saying yes, then this is what your answer is going to look like. It's going to be in two parts. You're going to have the GCF part. You're going to have what's left over. Okay? So let's do an example. We have here example A. We're going to factor. We have 8y cubed minus 48xy to the fourth. Make that a little bit brighter there. Okay? So, what you're doing here is just as a review here, okay? Let's write leftover terms. Okay, you can't see, okay. I want to, just as a review, okay? Needs to be focused, all right. Just as a review, okay? All right, so two parts. First, we want to find the GCF part. So what will be the greatest common factor for 8? Let's do it in segments here. 8 and 48. 8. 2 is a common factor. 4 is a common factor, but it's not the greatest. So 8. Okay? Now, do we have an X in each of these terms? No. So X cannot be part of the GCF because it has to be in both terms. But do we have at least a Y in each term?
Yeah.
Yes. So y cubed, y to the fourth, you choose the smallest. Y cubed. So that's your GCF. Okay? That was your first part. Your leftover part, this is what you find, how you find what's inside the parenthesis. You're dividing, once you find your GCF, you're dividing that GCF back into the original question to find what's left over. Dividing, the key word, divide, divide, divide. Okay?
When it comes to leftovers, we have to divide.
That's what you're doing. That's what factoring is. Whereas before, we multiplied. Okay, when we were talking about multiplying polynomials, we would multiply and add the exponents. But when it comes to factoring, you're dividing out and you would have to subtract the exponents. Okay? So, look at this first one. 8y cubed over 8y cubed. To what, though? 1. Okay? 8 divided by 8 is 1. Y cubed divided by y cubed is 1. Let me say this. Depending on the number of terms that your question starts with, should be the number of terms that you have inside your parenthesis. So you cannot be one less term. You can't say that it's nothing. 8y cubed over 8y cubed is nothing. It is something. It reduces to 1. We start off with 2 terms. What I write in my parentheses, we should all have 2 terms. Okay? So this is going to be 1. Let's do the next one. Minus 8 divides into 48. How many times? 6.
And negative 6 x.
And then our y cubed and y to the fourth. We're going to subtract 3 y's from out of 4. We have a y. But don't forget, what is there still? An x. So that's 6xy. This is what's left over. Okay? So, put your parts together. Here's your answer. Here's your GCF part. And here's what's left over. Now, eventually, and I'll do this one more time, I'm not going to show this part. I want you to understand, when you find the GCF, to write the remaining terms, you're dividing out.
If you don't get the GCF and it's still a common factor, what will you know by your answer that you didn't get the GCF?
Well, the thing is, if you, let's say that you got a GCF, you chose a GCF of 4. Even if you, when you check your work and you multiply it back in, you're going to come up to the original question. But inside the parenthesis, you still may be able to identify a GCF that's left over, which would be, well, I think a 2. You would take it out. It would still give you the 8. If I answer your question right.
Yeah, you did.
Okay, yeah.
So you'd still be able to continue with the work?
You still would be able to, it'd just be more work. That's why the rule says choose the greatest. So you don't have to do this in 2-3 segments.
Are we going to have like numbers in the hundreds and stuff?
Just
That's
might.
It starts getting difficult.
Well, even if you have numbers, it's going to be something that's doable. It may be 25 and 100.
Oh, okay.
Let me say something, what I've noticed in the years of teaching when it comes to GCFs, a lot of times those smaller numbers are the GCFs. And it divides into the larger ones. So if I give you 25 and 125, 25 divides into 125. Okay? It'll be workable. Okay? Now I'm not going to give you a 4 or 5 digit number to factor.
Yeah.
Okay, that'll be too much. Too much. All right, let's do another one. We have here 7x to the 4th minus 14x cubed plus 49x squared. All right, so let's look at the coefficients. 7, 14, 49. What would be the GCF? 7, yes. Then I ask myself, do I have at least an x in each term? And if I say yes to that, then I choose the smallest variable. Excuse me, x squared. That's your GCF. So, to find what's left over, you're taking that 7x squared and you're dividing that 7x squared into each term. But I want you to be able to do this without having to write leftover terms. 7 divides into 7. X squared divides into x to the 4th. You're subtracting. That means you're going to be 2 less in the exponents area. Okay? But here's why. Here, 7 divides out. X squared divides into x to the 4th. X squared times 7 divides into negative 14. We have negative 2. X squared divides into x cubed. X times. So we have 2x. Excuse me. And then 7 divides into 49. 7, the x squares divide out. And we have plus 7. So here's our answer. Our GCF. And then what's left over.